Hello viewers, welcome to my channel. I'm Hasham Ali Khan. This is the third theory video on probability. Last two videos I have explained you about the meaning, concept of probability, what are the different approaches to the study of probability, then what are the concepts which are specifically used in probability, then theorems, multiplication theorem, addition theorem, and lastly different types of probability, marginal probability, joint probability, conditional probability. All these things I have already explained in the first two videos. In this third and the last video, I am going to explain you about Bayes theorem and the application of Bayes theorem. Next video onwards, I'll start the problems on probability. So if you want the complete perfect knowledge, watch all the theory videos. In examination, not only problems, but theory question will be asked. What do you mean by Bayes theorem? What are the different approaches to the study of probability? What is marginal probability? What is addition theorem? So you have to be perfect regarding the theory concepts. So watch the video till the end. Don't skip in between. If you have not watched the earlier videos, I suggest you go to the playlist of my channel. Select the subject, this statistics for management. Select the videos of probability. Watch all the videos till the end. Get a full command on the topic. Now before starting the Bayes theorem, take the screenshot of the points regarding Bayes theorem, then I'll explain everything in detail. Now, a frequently asked question in examination is regarding what is Bayes theorem, and a number of problems will be asked in examination regarding Bayes theorem. So, the contribution of Bayes theory consists of primarily of a unique method of calculating conditional probability. First of all, this Thomas Bayes, he was a mathematician. He has given a unique method of calculating the conditional probability, and this conditional probability are very much of use for the management, for the executives to take the decisions. So Thomas Bayes has given the method how to convert the prior probability into posterior probability, or unconditional probabilities into conditional probabilities, how it should be converted. That's what given by Bayes theorem. The probabilities before revision of Bayes rule are called prior probability. So we have two sets of probability. The probability which are unconditional, without using any additional information, that probability is called prior probability. That is the probability which is not yet revised. Unconditional probability is called prior probability. And the probability which has undergone revision in the light of sample information is called posterior probability. So the prior probability has to be revised, has to be changed by using the additional information. So we have two things, prior probability and additional information. So this additional information will be used to revise the prior probability. After revising the prior probability, we will get a set of posterior probability according to Bayes theorem. That's what. Now, since it represents a probability calculated after this information is taken into account. Just now I told you, information is there. By using that information, we are going to change the probability or revise the probability. That revised probability is called posterior probability. Posterior probability are also called revised probability in the sense that they are obtained by revising the prior probability with sample information. The other name of posterior probability is the revised probability, because we are revising the prior probability with the additional information. We are combining the additional information with the prior probabilities to get the posterior probability or revised probability. Now, thus a prior probability which is unconditional probability becomes a posterior probability by using Bayes rule. So simply, Thomas Bayes has given a method, a rule, how to convert the prior probability or unconditional probability into revised probability. Now, Thomas Bayes, a mathematician, developed a theory that helps in calculating the probability of an event based on additional information made available. So whatever additional information is available, using that additional information, we are revising the probability. That is Bayes' theorem. Now, specifically, how the Bayes' theorem will be applied, how we can convert the prior probability into posterior probability. Here I have given one example. By using this example, we can be able to understand how to convert the prior probability into posterior probability. Thomas Bayes' theorem states the following. Let E1, E2, E3 up to En be n mutually exclusive and totally exhaustive events and with non-zero probabilities. First of all, imagine there are events. The events are E1, E2, E3, E4 up to En. And these events are unconditional events. Non-zero probability. Non-zero probability for these events. And totally exhaustive events. It is not infinite, but finite number of events. And A, be any event that can occur only if any one of E1, E2, E3 events occurred. Then A is a conditional event. This A will occur along with E1 or along with E2 or along with E3 or E4. So for any E1, E2, E3, E4 up to En, we are having a separate event. A is a separate event which will happen along with E1 or along with E2 or along with E3, like that. Now let the probabilities of each of the events are given. We are given the probabilities of E1, E2, E3, E4. So we can denote it as P of E1, P of E2, P of E3, P up to P of En. These are the unconditional probabilities of event E, right? And be known. And the conditional probability. The conditional probabilities are the probabilities of A given E1, A given E2, A given E3. That means what is the probability of A given that E1 had happened? Then probability of A given that E2 had happened. And probability of A given E3 had happened. So these are the conditional probability P of A given E1, P of A given E1, P of A given A2, P of A given A3, like that P of A given En. These are the conditional probabilities or additional information. So we are having two probabilities. First, unconditional probability, that is P of E1, P of E2, P of E3 up to P of En. Then we are given the additional probability, conditional probability. The conditional probabilities are P of A given E1, P of A given E2, P of A given E3, etc. up to P of A given En, right? Then the conditional probability that event E1 will occur given that event A has occurred. We have to find out what is the probability of E1 given that A had occurred. So simply I can write P of E1 given A. That means A had already occurred. What is the probability of E1? So P of EI given A. I stands for 1, 2, 3, 4, any number of events. So P of EI given A is equal to P of EI into P of A given EI. So numerator is this one, joint probability. Joint probability means the product of unconditional probability and conditional probability. This P of EI is unconditional probability. P of A given EI, this is the conditional probability. When you multiply both, we'll get the joint probability. Divided by sum of the joint probabilities. Sum of the joint probabilities of all the events. That means summation n, I is equal to 1. Then I is equal to 1, 2, 3, 4 up to n we can go. So denominator P of EI into P of A given EI plus P of E2. If suppose we are having 1, 2, 3 events, so all the products will take P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus P of E3 into P of A given E3. Like that, all sum we will take in the denominator. So simply, the product will be taken in the numerator and the sum of the products will be taken in the denominator. That's it. Let us understand the above theorem by taking just two events, E1 and E2. For easy understanding, I am taking only two events, E1 and E2. Actually, it can go up to En. But for simplification, for understanding purpose, I am taking only two events, E1 and E2. So, probability of E1 given A. Probability of E1 given A. That means A had already occurred. What is the probability of E1? Is equal to joint probability. P of E1 into P of A given E1. P of E1 into P of A given E1. This is the unconditional probability, this is the conditional probability. Multiply, we'll get the joint probability. Denominator will take the sum of the joint probabilities. The joint probability are P of E1 into P of A given E1. This is the first joint probability. Plus second joint probability, P of E2 into P of A given E2. So this is the joint probability and this is the sum of the joint probability. Two probabilities are given, two joint probabilities are given. Similarly, P of E2 given A. This is P of E1 given A. This is P of E2 given A. The numerator will take the joint probability P of E2 into P of A given E2. Because we are finding out E2 here, P of E2 into P of A given E2. Denominator, the sum of the joint probability, same formula what we have applied here. P of E1 into P of A given E1 plus P of E2 into P of A given E2. That's all. This will give you the probability of P of E2 given A and this is P of E1 given A. These are called posterior probability. According to Bayes theorem, this P of E1 given A, P of E2 given A, E2 given A is the posterior probability. That's all. This is the theorem. Now, application of Bayes theorem. How the Bayes theorem will be applied, why it is applied. First of all, in Bayes theorem, posterior probabilities can be known by revising prior probability with the help of new information. So, in the Bayes theorem, the posterior probability can be obtained by revising the prior probability with the additional information. So here, these are the prior probability P of E1, E2, E3. And this P of E1, E2, E3 prior probabilities will be converted into posterior by using additional information, conditional probabilities, right? Secondly, the probability of occurrence of future events can be known by Bayes theorem. So Bayes theorem will be used for calculating the future events, future probabilities. Then Bayes theorem acts as a powerful statistical tool. So in the entire gamut of probability topic, the Bayes theorem occupies a very important role. So it's a very important statistical tool in probability theory. And Bayes theorem helps the business and management executives to take effective decisions on uncertain situations. The main function of the management is to take the decisions. And this Bayes theorem will be a very handy tool in the hands of management executives to take the decisions in uncertain situations. Bayes theorem is also known as probability of causes. Why it is called probability of causes? Because as it helps in determining the probability which a particular effect has due to a specific cause. What is the effect on the probability due to a particular cause? That's why it is called probability of causes. That's all. So, in this video, I have explained you about the Bayes theorem and the application of Bayes theorem. This marks the end of the theoretical part of probability. Inshallah, we will continue. We'll start the problems on probability in the next video. So, if you are satisfied, give a like to the video. Share my channel among your groups, among your friend circles so that more students can watch the video and enhance the knowledge. Give your comments. And lastly, don't forget to subscribe. And by the super thanks which is given below my video, inshallah we'll continue the problem in the